हरिः कर्ता।
So, in the overall process of supervised machine learning process, we are in third step, which is EDA, exploratory data analysis. So in this, so far we have seen data profiling techniques, organizing data techniques, summarizing data techniques. Now it's time to get into the fourth step, which is pattern discovery. So here we will be looking into K-means, hierarchical clustering, association, rule mining to discover interesting relationships between variables. Here we won't be dealing these algorithms in detail. However, we'll have a rough understanding about them with a simple example. So if you see, look into the overall systematical usage of techniques under EDA, you should get the accurate representation of EDA and how it works. So obviously, once you get a data, you have to explore for the profile of the data. Once you're damn sure about the profile of the data, then you can get into the organizing the data category. So there we will do the sorting, categorization, tabulation, visualization. Once that is done, we will get into summarizing data. Here we'll get more lot of information regarding the data. Once that is done, now it's time to use some unsupervised unsupervised machine learning models to get the hidden patterns of the data, so which cannot be discovered through summarizing data or through organizing data or through any other process. So that is the reason we will leverage the power of unsupervised machine learning models under the exploratory data analysis. This is very, very important. So leveraging the power of unsupervised machine learning models under exploratory data analysis of supervised machine learning model is ultimate, because we get a high level of insights, hidden patterns of data. So with this, the direction of the analysis, the direction of your project could also change. So that much of power this uh, pattern discovery or unsupervised machine learning models we have. Anyway, so let's get into the pattern discovery under exploratory data analysis. However, we will begin with K-means clustering. We'll begin with K-means clustering. So what is K-means clustering? So K-means clustering intends to partition n objects into k clusters. You have n objects, n data points. Let's take it as n data points. So we just want uh, to cluster, we want to make that n objects into k clusters, so in which each object belongs to the cluster with the nearest mean. Okay, so this method produces exactly k different clusters of greatest possible distinction. So the best number of clusters k leading to the greatest separation, that's basically a distance, is not known as a priori and must be computed from the data. So the objective of k means clustering is to minimize total intra-cluster variance or the squared error function. So what is that squared error function that we're gonna explore now? So K means is one of the simplest unsupervised learning model or learning algorithm that solve the well-known clustering problems. The procedure follows a simple and easy way to classify a given data set through a certain number of clusters. Assume k clusters fixed a priori. The main idea is to define k centers, one for each cluster. So these centers should be placed in a cunning way because of different location causes different results. So the better choice is to place them as much as far away from each other. So the next step is to take each point belonging to a given data set and associate it to the nearest center. So when no point is pending, the first step is completed and an early group age is done. So at this point, we need to recalculate k new centroid as a very center of the clusters resulting from the previous step. So after we have these k new centroids, a new binding has to be done between the same data. So set points and the nearest new center. So a loop has been generated. As a result of this loop, we may notice that the k centers change their location step by step until no more changes are done, or in other words, centers do not move anymore. So finally, so this algorithm aims at minimizing the minimizing an objective function known as squared error function, which can be given by the following equation. So j of v, basically we call it as objective function. So we want to minimize this objective function to get a proper result. So that's what the uh, aim of this algorithm. So the main aim of this algorithm is to minimize an objective function, which is nothing but as squared error function. So k is a number of clusters, n, so total number of rows you have or total number of data points you have. And here this is called cj, is centroids for cluster j. Okay, we have j is equals to 1 2 k is equals to 4, so we'll have 4 clusters. J is equals to 1 2 maybe 5, so we'll have a 5 clusters. So then c1 c2 c3 c4 c5, total 5 clusters we'll have, and cj is nothing but centroid for each cluster, and xi is obviously your specific individual data point, and xi minus j minus cj whole square is known as your distance function. So, and the cj is nothing but your mean of respective data points divided by 1 by n. That's is your cj, the centroids for cluster j. So basically, whichever data point has the minimum square of distance between a particular centroid, and that data point will belong to particular centroid. For example, if we want to make it 4 clusters, then each data point's distance will be calculated with the 4 cluster centroids. It will start randomly, but slowly it will pick up. Then with which centroid of the cluster it has a lesser distance, and the point will be allocated to respective cluster. So that's how the k means clustering works. However, so this is just a we are just discussing at the top level. So once we get into the unsupervised machine learning models, there we will deep dive into this, and we will be explaining. I'll be creating an intuitive, experiential uh, visualization to understand K-means. But for now, let's get into the algorithmic steps for K-means clustering. So the first step, it will begin with, certainly, let's look into the steps one by one. So certainly, K means clustering is an unsupervised machine learning algorithm used for partitioning data set into distinct groups or clusters based on their similarities. So obviously the first step here is to initialization. So initialization is nothing but, we have to choose the desired number of clusters that you want to create. So how many clusters you want to have, the number deciding the k value is very important. So whether you want to have a 3 clusters or 4 clusters, that you have to decide. So choosing the desired number of clusters is very important. So once that's done, now it's time to initialize k centroid k centroids randomly or using some predefined method. So what method we are gonna use for this, that we'll see with the example. So once the first step, initialization, is done, now let's move on to the second step, which is assignment step. So once the number of desired clusters has been decided, and then we have initialized the centroids k, now it's time to calculate the distance between each data point and all centroids. That's what the next important step. So once the distance has been calculated between the data point and the centroid, now it's time to assign each data point to the nearest centroid based on the distance between the data point and centroids. So usually we use Euclidean distance. Then it's time to create k clusters, where each cluster contains the data points assigned to a specific centroid. So third step, update step. So calculate the new centroid position for each cluster by taking the mean of all data points assigned to the cluster. So then update the centroid positions. And fourth, iteration. So repeat the assignment and update steps, that's 2 and 3, iteratively until the convergence happens. And convergence occurs when the centroids no longer change significantly or a maximum number of iterations is reached. This is what is called convergence. Okay, this is what we call it as a convergence. Once there is not much of a change, if there is no significant change in centroids, or a maximum number of iterations is reached, so that's it, we have reached to a convergence point. So then fifth, final result. So the algorithm converges and each data point is assigned to a cluster. So the final cluster assignments represent the output of the K-means clustering algorithm. So it's important to note that K-means clustering is sensitive to the initial centroid positions and can converge to local optima. Therefore, multiple runs with different initializations are often performed and the best result is selected based on some evaluation criteria such as minimizing the within cluster sum of squares. We also call it as a inertia, or maximizing inter cluster separation. So now what we are gonna do is, let's take up an example for this, and we will do the clustering for certain data points. So the first one, we will begin with k means clustering. K means clustering. So as usual, the first step is to import the required libraries. So in this case, I will call upon pandas. That's the minimum requirement. Import pandas as pd. Then obviously I require to import Kmeans module from sklearn library and cluster package. So from sklearn library and cluster package, you got the cluster package, and I need to import k means. So that's it. The importing is done. Now it's time to load data. It's time to load data. So let's load the data directly. So I'm going to take up data is equal to pandas dot read csv, and I'm going to go for the, let me go for soccer players data one. Okay, this is what our data's soccer player, and let's do self testing here. So if name is equal to main, just print data for me, and here is your data set. Or let me ask, let me print the data set, and this is what is. Okay, so this is how our data set looks. So now it's time to move ahead. So I'm not actually taking through actual machine unsupervised machine learning process. When we are in unsupervised machine learning course, that time I'm going to take you through all steps one by one. At this moment I just want to give a rough understanding of how we can leverage the power of unsupervised algorithms in exploratory data analysis. That's the reason I'm just taking a simple example. I have a ready-made data which is processed, absolutely finely processed. I don't want much of changes to this data. So loading the data has been done, and on other side we are doing self-testing also. Absolutely no issues at all. So now it's time to select the features for clustering. So now let's select the features for clustering. So let me say X. Obviously those are our future features, and everything is featured because it's unsupervised. It's not distinguished or not identified or not labeled as this is dependent and this is independent. So here, so no particular column has been labeled as independent or has been dependent. So everything here is absolutely, there is no labeling as such y and x. So everything is x here. So that's the reason. Let's take x. These are all our features. So let me take up two variables here particularly. So I'm gonna go for 2. So 1 is height in centimeter, and second one is weight in kg. Yep, that's it. That's what is your data which is ready. Let me print X and see how it looks. And this is your X. These are our features. It's also a data frame. And if you want to check what is X, and let me call up print X, and let me see the shape, or let me directly say type of X. And what you'll find is obviously a data frame. Okay, so that's what is our X. Okay, now let's move ahead. So now it's time to perform K-means clustering. So it's time to perform K-means clustering. So perform K-means clustering. K-means is equal to, obviously K-means module I brought down. So now I have imported. Now it's time to create or instantiate the class object of K-means, and that's what I'm gonna do. So inside that I have to give instance attributes or instance parameters. So I'm gonna go for n clusters. Let me begin with 3 clusters. Basically, this is what the K value that we have discussed earlier. So that's is 3, and random state I'm gonna go for 42. So random state, widely people use 42. I'm also gonna use 42. So now it's done. Your instantiating the class object is done, or instantiating the instance K-means object is done. K-means instance is done. Now it's time to fit data. It's time to fit the data. So let me say clusters is equal to K-means, and that is our object. Now it's time to call a method called fit underscore predict from the K-means object. So for that I have to refer the K-means, and I have to say dot, and I'll say fit underscore predict, and this is what is gonna fit your data into your algorithm, and it's gonna make the clusters, and here it is. So if you want to check what it is, that, so print let me say type of clusters, and what you can find here, it is it's a numpy and the array. So that's what we got it, because it's what you get at the end of the day. It's a data, so that's the reason. So now let me say K-means. What is K-means? And what you got here is K-means is a K-means object, because we have instantiated that K-means object from K-means class from sklearn library and cluster package, and that's what you can see on the screen too. Okay, so all done, all set. Now it's time to get cluster assignments and centroid positions. That's what the most important thing. So let us get cluster assignments and centroid positions. So cluster underscore labels is equal to K means dot labels. So now let me go for the centroid underscore positions is equal to k means dot cluster underscore centers. So we got the cluster assignments. Cluster assignment is done, and centroid positioning is also done. Now it's time to analyze and visualize the clusters. All set, all done. Okay, now it's time to analyze and visualize the clusters. df is equal to pd data frame. So let me put the columns here. So let me copy this. These are the two columns I'm going to use. This is our data set, and so df of cluster is equal to cluster labels. So the cluster labels also has been assigned. So if you want to see the df, what is df, let me print df, and this is what is your df. So this is what the final data frame, and this is height, this is weight, and this is how. So cluster 0, cluster 1, cluster 2, the data has been converted into 3 clusters. The cluster number that you can see here, 0, 1, 2. Okay, this is okay, but if you want to have a visual, if you have a visual representation of the same, it makes more sense. So that's the reason. So we will be making a visual representation of the same. So let me print. Okay, here let me print the df dot head, that you can see. This is what the final result that we have want. df dot head. Next, so it's time to create the visualization of our clusters. So let's do that. So visualizing clusters. For that, I need to import matplotlib pyplot as plt. So let me make a plt dot. I just want to make the scatter plot. So let me say, let me create fig and ax, two objects. One is figure object and second one is axis object. And plt dot subplots, and you see that the empty subplot has been created. And here you can see your data set has been clearly clustered into 2, 1 and 0. So and here we are going to create the visualization of the respective clusters, and let's do it. So let me bring this down and put it here, and this one anymore, it's not required anymore. So this is for the self-testing, so I have done it. I will remove this. Okay, that's it. Now it's time to plot. So basically plotting clusters. So fig, and here is your plot, empty plot. Now I need to attach. So ax dot scatter, and the inside it's gonna take up x weight kg. Yep, and that's our first x, and On other side, I'm going to take up weight. The weight has been taken first. Then let's give height. Height in centimeter. So let me just copy it from here. Just a minute. Okay. So x and y has been given. So now the most important one, to make the clusters, I need to give the third parameter as cluster labels. That's very important. That's it. Your scatter plot is ready. Here is the magic and looking brilliant. Three clusters, cluster 1 and cluster 2, but we have to do a lot for this figure to look beautiful. So we need to attach some aesthetics. So now it's time to add a label x dot set underscore x label. So obviously I'm gonna go with the x label is height in centimeter. Then let's go for the weight y label x dot set underscore y label. This time I'm gonna go for the other one. And what's next? It's time to set up the plot. Sorry, title x dot title, which is k means clustering. K means clustering. And finally, it's time to say show. And here it is, your clusters. Okay, just a minute. There was some issue. So let me change this to set title underscore title, and here it is. The issue solved. That's it. See that? You can see your data set has been clustered into three clusters. So it makes some sense, but still I find some issues with this. Okay, but we need to mark uh, the outliers also. So that I'm gonna do now. So let me mark the outliers here. So below this, so let me say ax dot scatter. So centroid positions and 0, and let me put the centroid positions again. This time 1, and C, I'm gonna go for the red color. Then I'm gonna use a marker of cross, and that's it. How nicely these things has been marked. These are completely out of the clusters, and this is what you're getting. So now what we are going to do, this is when we have chosen a cluster of 3, this is what we got. Now it's time to do a minor changes to this, and we'll see how it looks. Let me make it to the 4 clusters. Let me check. How does it look? Of course, you see that. So this data is proper. It seems a cluster. This is absolutely proper cluster. This is absolutely proper cluster, and the last one has some longest distance data. However, these data points will, the distance for these data points with the other centroids would be huge. So that's the reason these were clustered into this. But however, the fourth cluster is not so keen, and the number of outliers has increased. So this, I don't think this is also proper. Let me go for the another cluster. So I'll increase to the 5 and see how it looks, and it makes some sense. It's okay. So your the points which has been thrown out of the clusters are 5. It's increased, and this cluster seems good, this one good, this one good, this also makes sense, and finally this one has some huge, of course this also makes some sense. They'll have average distance would be higher than compared to the other cluster. So let's make the final attempt to understand the hidden patterns. So let me make it to the 6 and see how it makes sense. And of course, it looks better, but you have to do the enough analysis using the domain expertise, and you have to come up with the proper clusters. But however, this last cluster can be made as a one cluster, so it makes sense. It makes sense more than the clusters with just three clusters. You see that here these are very close and these are too far. This one and the first yellow cluster and blue cluster was by and large is okay, but when it comes to the last cluster, you can see the distances are too high. So that's the reason I would prefer other clusters than compared to this. Of course, if you are able to uh, make if you are able to understand these clusters with respect to your domain, and if it makes sense, if it makes domain sense, then I would go for 6 clusters, because I can see the difference. So each clusters are heavily packed here. So this cluster, and on an average distance, other than taking out this outlier, so this makes some sense. So I would go with this, and this is what is K means clustering.